Okay, we're gonna do the insulated copper today. We got a few slides to go through. We gotta go through more than a slide per minute if we're gonna make it out of here in 30 minutes. Okay? You know, some people might remember the amount of that cheap trailer tow job that I told you that somebody did on their own Thunderbird, and they put a Scotch lock in there on that little 22 gauge brown wire that goes to the tail lights, and they hooked it up to their boat trailer and they drove to West Bay or somewhere. And when they got to West Bay, they switched it off, and it wouldn't switch off. The engine kept running, and some of the lights were on all the time, and this kind of thing. So when they got it back up there to the dealership, and I got to look, and I saw where they had put that Scotch lock in there, and it had started burning that wire, and it burned all the way through the wire harness, and it melted that wire into a bunch of other wires all the way through the whole wire harness, all the way up front, all the way across under the dash. It was an awful mess, all because of one Scotch lock. Now, a Scotch lock in and of itself is not a bad thing, but if you don't use it right, you don't understand the fact that a 22 gauge wire cannot carry all the lights on the trailer plus the ones on the car. The 22 gauge wire was made just to carry that one. All right. So this is where he put the. I got the way to get it on, but that one there is about right here is where he put the Scotch lock. And what it does is it starts burning the wires back in the direction of the power. And it started melting it like a slow burning fuse, almost like, but it didn't take a long, I mean, it didn't happen quick, it happened really slowly. It just blistered and burned it all the way up through here. This is where the harness, you put it on the harness, you see the little orange trail on the harness, it burned it all the way up through here, burned it all the way through here, and then it picked up here, and it burned it all the way across there. And it melted into a whole bunch of wires. It was an absolute disaster, and this was a brand new car. Okay, so the entire wire harness, I had to pull the door panels off, I had to pull all these panels on the inside, take the seats out, had to replace all of it, had to pull the dash out of the dang thing, had to replace all that wire. All because the Scotch lock was applied right there, because this guy thought he knew. What is that? We're 6 minutes into our lecture, and we all had a phone call and a watch noise, okay? The wires feeding the tail lights are at best 22 gauge wires. Now these are the sizes of your different wire gauges. 22 gauge is 200, is 25 thousandths of an inch basically. A spark plug gap is 40 thousandths of an inch. So think about that. The copper part of that 22 gauge wire is smaller than a real tight spark plug gap. It's about like a lawnmower spark plug gap. And that's a little bitty wire. Big enough for the Thunderbird, but not to carry the trailer lights, right? Okay, so here's test question one. When using a digital multimeter function to check for a voltage drop, the meter lead should be connected in which of the following ways? A, on the positive side of the circuit, B, across the component of the circuit, C, in any non-conductive material, or D, in series with the circuit. The slide will change in 5, 4,
My pen isn't anywhere.
2, 1. All right, burn this in so you won't burn things out. Okay, that's a nice little thing to remember, right? Here's your little relay, and you can buy these relays right here. And this is from B+, it's gonna go in on your common. That's usually how it's wired whenever you're doing something like this. And your trailer lights, should be going out on that one from the existing light feed, with your little Scotch lock from your brown wire. If it was gonna go anywhere, it should have gone in here. And then it's just only pulling a very, a tiny whisper of current. Not very much current on that circuit right there, pretty good bit on this one right here, particularly when you're driving to West Bay, okay, from somewhere over there. Well, I've seen more than a few of this. As a matter of fact, I had Zane working on this deal out there on live wire a while ago. See all these running board lights and all this fancy stuff? They say, I'm going to put me some running board lights on my truck, and I'm going to do that. So they go find this brown wire, the same one I'm talking about, that goes back there to the light, and they bite into that sucker. And then they come in later and none of their tail lights are working, and their headlight switch looks like this. See the burned up connector? It just destroys it. All right. Anytime you got an electrical current flow, it's going to find a weak link. Wherever if it finds a weak link, it's going to start generating heat. Okay. And whenever it generates heat, that requires replacement of that. Sometimes the plain old headlights, if you start getting oxidized terminals, will do that. All right, notice how the factory did it on this truck right here, where you had those. They had a trailer marker lamp relay and a trailer adapter. See, if it comes with a built-on, if it's built-on trailer adapter, they're actually going to have that. Now, in some cases, the stoplights will go directly to the stoplights on the truck, but they always have the tail lights going from the relay every time. All right, the 95 Explorer headlight story was one that you might remember. This headlight switch is like what the 95 Explorer has on it. It looks like that. Wires plug in like this. And I've talked about this one before. It came into the dealership and they said, we drove to Tennessee last night, or this weekend, and when we came back, you know, we didn't have any headlights, but we had the headlights on all the way up there. And so this was an 8-hour drive with the headlights on, and the switch comes back burned out like this. And so I says, well, how are we going to prevent this from happening again? I was able to get a pigtail connector, it's brand new. I was also able to get a new headlight switch, but I didn't want them driving and have their headlights burn out again. And so this is what it looks like in the ones without auto lamp. This is how it was wired up, right? So you got this fuse going through the headlamps, and it comes out here to the multifunction switch. It goes through there. Why? Why does it have to go through the multifunction switch? Dim and bright, man. You know, when you turn on your lights, you're either going to have dim or bright. You won't be able to pick. So it's going to have, these switches are wired how? In series, right? So it's going through the fuse, through that switch, through that switch. That's a series circuit, isn't it? Every day of the week. So when it goes to, now when you flip it over here, if you got flash to pass, you know, you got a separate circuit driving that. But the simple fact is, I mean, with most vehicles you do, this is what you do. Watch what I did. You see how the schematic changed? You cut that wire. You cut a wire. That sounds horrible, doesn't it? Oh no, we clipped the wire. Snip. Oh no, we're trying to plant a bug, right? All right, you notice our relay is already, the coil is already grounded on my relay, right? You got it? Okay. Let's stop for a second. Which of the following is correct regarding a series circuit? The highest resistance has the most current, the lowest resistance has the most current, the lowest resistance has the highest voltage drop, or the highest resistance has the highest voltage drop. Think about that one for a second. You gotta move on. Highest resistance has the most current, lowest resistance has the most current. Lowest resistance has the highest voltage drop, highest resistance has the highest voltage drop. All right, now then, now that we've cut that wire, we connect that to the coil. So what happens now when we turn on the lights? When we turn on the lights, now we're just energizing the relay, right? The relay's energized, click. Okay, now we've still got to get power back over here somehow because that's got to be hot so that you're going to have lights, right? Okay, so the relay normally open feeds to the dimmer, multifunction switch.
Explain to me why you put a relay in there.
Huh?
What was the purpose of putting the relay in there?
Because the switch wasn't able to can't handle the load of the lights. It burned up on a long overnight trip to Tennessee when the vehicle was brand new. Okay. You've got to splice into the hot wire that's feeding the headlamp switch, so the same fuse is still protecting the light circuit. But it's this part, this switch right here is a lot stronger than that switch right there. With this out of the circuit, this was having to carry a load they miscalculated. And you might remember I got a call about 6 or 7 months after I came to work here at the technical college, this was back in 2001, from a Ford engineer. And he says those headlight switches were burning up on cars over in Europe, and he needed a field fix. And he noticed the one that I fixed back in 1995 never gave the problem again because he had the warranty history of the vehicle. What did you do to fix that so that it never happened again? I said, I put a relay in there. Now, how did you wire it up? Seriously? This guy's an engineer and he goes to me and tell him how to wire it up? So I sent him the schematic just like I showed y'all. And he wrote a field fix for the cars in Europe using that fix. Add a relay, fairly simple to do. All right, so, I mean, I'm sure there was more to writing a field fix than just a schematic. All right, so, and that's the schematic I sent to the guy right there. Okay, damage by heat. Pay attention to where you're routing the harnesses. You can't just drag a wire across anywhere, right? This one here was laying too close to the EGR, and it burned that blue wire. That blue wire, that car came in with a charging system fault and a code that was being thrown for the field circuit on the alternator. This was the Ford Focus, I think, one that I worked on. And that harness was laying over against that EGR valve, which gets very hot when EGR is flowing, right? And it had melted through this, and that wire there had been damaged too, but this one here was the one that was throwing the code and causing the problem. Now you need to fix those wires, which is what I did on that. Even if you have to clip them apart and solder them back together and all that, and tape it up, make sure you tie it back out of the way. Make sure you keep your wires out of trouble, that's the thing. This one here was pinched. That is an easy mistake to make. Pinching a wire when you put a bunch of stuff back together. I don't know, at the time I've seen people pinching between the engine and the transmission, or pinching between a bracket, or they're putting something on the trailer, you know, trailer tow, I'm talking about a trailer hitch, you know, put on there, and they'll pinch wires and all that stuff. This one right here was rubbing really hard against that AC line, and it basically got in there and just breached all kinds of wires. You can see where it was rubbing, and you can see where that one was. That's damaged by chafing. Also dragging across a sharp bracket, it just saws into it. Insulation issues, what we got here. And, Stacy, what you need, Sue? She's ready to go. You got her part. I mean, her. All right, yeah, she's ready to go. I just haven't marked her ready. All right, so that's what this insulation. You ever seen insulation do this? All right, Ford Contours had Japanese wire, and it was awful this way. And there was a recall. All right, there's the recall paper. That's what the recall looks like. 99 MO3s, certain 95 to 97 Contour with speak, underhood wire harness, additional coverage, and you had to pull all the wires out there and throw them all over the floor and, you know, replace them because those wire harnesses were bad. All right. Hello. When a digital multimeter is used to measure DC voltage and is connected in a parallel to the load device, which of the following defines the reading? Is that amperage reading, voltage drop, voltage spike, or pulse width modulation? You're connecting it parallel to a load. What are you measuring when you connect a digital multimeter parallel to a load? 5, 4, 3, 2, 1. Then there's the benders, the ones that connect to components like the shifter that move back and forth a lot. Each time they bend the wires, and eventually you wind up with a connector that looks like that. Them things just got broke off, slam up against there. This was on a 2006 Impala. Suddenly she couldn't get it out of gear. Look down in there and you got broke wires and all that, you know. Now this is, if you do this right, it only works every time, right? So you take this right here. You see how I took that used to be crimped in there? I took that, I cut it, I put the little insulation around it, I slid that up on there, I pinched that around the insulation, then I soldered it. I have made this wire so that it can go back into its original connector shell, and we've got a good solid connection that's better than actually the one that was there before. And so that's the picture. I've also got it there, see? All right, so connections that are near the battery can take on this kind of garbage when they do. And you can't always see that without unplugging the connectors. If you got connectors that are near the battery that you think are suspect, pull them apart, see if they got corrosion in there. Current stops flowing. This one here caused a transmission problem related to the speedometer. And it happened to be a connector out there near the battery that did that. Which of the following tools can be used to check the continuity of wires that carry digital signals? A megameter, an amp probe, a logic probe. Now, believe it or not, a megameter is an actual tool. I mean, it actually is something that puts a really high voltage in there to see if it's leaking. You use that for hybrid vehicles. Amp probe, logic probe, or voltmeter. Moving on to the next question in 5, 4, 3, 2, 1. Actually, the next slide, not the next question. Now, current flow heats connectors, and sometimes they start to oxidize, and that increases resistance, and that reduces current flow and creates heat. And fan circuits do this a lot. Fan circuits are the world's worst to do this, because fans, they blow and they actually pull a lot of current while they're spinning and all that. And you'll see them like this. That's actually on a blower resistor that burned up. The wires right there. And anytime you got a blower that's not working, always suspect the connections at the fan motor or the resistor, because if you pull that blower resistor loose, and y'all seen that a couple of times this semester, I think on them some of the Ford Fusions, you know how the fan wouldn't quit working and you unplug it and they're all blistered and burned there at the blower resistor. That one right there, if you'll remember, was a fan motor fuse on a 2004 Chrysler Sebring. It was trying to overheat because the cooling fan wasn't working. That fuse wasn't blown, it just overheated. The first time I started seeing this was on some of the Ford vans, that the blower motor fuse, the little glass fuses in there, would actually start to get really hot and melt out of there. They weren't blowing the fuse, they just had enough heat built up there. So what we had to do on those was cut those two wires loose from the fuse panel, put a circuit breaker in there with the eyelets and nuts on it to protect the circuit, yet we didn't want to, to get hot and burn that thing up again. This is what happens when you spill toner all over your desk. If you ever do anything like that and say, crap, I can't believe this happened. Poof. I mean, it's just all over the place. Huh?
Did you do that today?
That was actually about 8 years ago. But it's always a question, it's always a thing I like to throw in there. Okay, so, well, you know what was cool about that? All I had to clean it up with was a vacuum cleaner. Didn't hurt a thing. Just woo, sucked it off there, you could never tell it was there. Because it doesn't ever make a stain until it's got heat. See, now if I'd heated it up, it would ruin my papers. But that's disgusting when that happens, though. That orange hand cleaner is what we use back then. Okay, butt connectors are cheap and easy, but they're not good unless they have the heat shrink cover, which makes them slightly better. These are ones with heat shrink color. If you tin the wire before you put it in there and pinch it, you've almost got a good connection. It's as good as a solder joint. If you just put the wire in there, that does kind of pretty much keep the weather out, because this right here has got some gummy stuff that'll sweat in there and seal them. These right here, if you're going to go very far with any of them, I don't think so. I mean, I do not like those, especially for pulling any kind of significant load. These right here are a little better. They're even better if you tin them, but if you solder and heat shrink, that's the best of everything, as far as I can tell. Tinning helps the shrink with even more. Now, wire harness overlays and routing are extremely important. What if you're in a situation where you know where the circuit starts and you know where the circuit goes, and you don't want to have to split a doggone wire harness that goes here, there, yonder, from pillar to post? I just want this thing to work so I can move on to the next job. So what you can do is you can get some split loom, which doesn't cost that much, pull you some wires through it, run them in a way that makes sense, that looks good, and whenever you get that run through there, as long as you don't have circuits that are splitting off of that circuit going other places, you can run an overlay. And it's painless, it's quick, it makes the thing work again, and you don't need to know exactly what happened unless there are problems somewhere else. Just run another wire. That's the best electrical thing to do, right? As a matter of fact, some of these network people will pull several network wires in case one of them goes bad. They'll just switch to another wire that's not being used, you know. Same thing they're doing, basically. And nothing wrong with doing an overlay as long as you don't leave out branches that are feeding other things. Now, when you're doing something like courtesy lights, you know, the cat's on the roof, because it actually going to go to one, it's going to go everywhere, you know. Like, all right. So using a digital multimeter, a fully charged 12-volt battery should indicate how much voltage. Open circuit voltage test. That's the battery sitting on the bench. That's when you touch your meter to the two battery terminals. What should I read? 9.6, 4 volts, 1 volt, 12.6. This one here quit and wouldn't restart. It had no spark and no fuel injection. Now, I've run into a situation like this more than once in my career where it just didn't make sense. It was stupid that I found what I found. And whenever I found like for example, you feel like if one of these jumper wires doesn't work, you can always find, if you're wanting to, what's wrong. It'll be up here, maybe it's broke on the inside, maybe it's been pulled out or something like that. All right, this particular one, this circuit right here, profile ignition pickup from the ignition control module to the powertrain control module. What is that used for, do you remember?
What's it called?
Profile ignition pickup. It actually is the reference signal that it uses for fuel injection, and it also tells what engine RPM is. In other words, fuel injection frequency, not pulse width necessarily. But as the engine speeds up, you know, the injectors start out when it's idling going click, 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 and as you pick up speed, it goes click, 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 click. You know, it's going to do that, but it can modify the pulse width based on other things. But the simple fact was, this guy here had no spark, no fuel injection. All right, and so what I found when I hooked the SPDS machine up, I remember on that Thunderbird, at 94 Thunderbird, I remember the ignition control module not being here, which is where the all-data is. I remember it being down in here. And there's a harness that goes through a plastic loom over the top of the shock tower, and the PCM was back up in here. That's why I had those two yellow wires. Two technicians are discussing a battery state of charge. Technician A says a specific gravity of 1225 at 80 degrees Fahrenheit indicates the battery state of charge is approximately 75%. Technician B says you can use a hydrometer to check a battery state of charge on a maintenance-free battery if it has caps. Who is right? A only, B only, both A and B, neither A or B. Can you read the table down here? slide moves in 5, 4, 3, 2, 1. The schematic block diagram of that 94 Thunderbird looks like this. The ignition module is a separate component on that one. The powertrain control module. This thing actually would send the ignition. This was high data rate EDIS. The ignition control, the powertrain control modules, when it sent the ignition module, well, they call it there was spout on the old system, they call it SAW, which is spark angle word. And when it send that over there, it would basically request a particular spark angle. Because this sucker here was responsible for firing the coils, the camshaft position sensor, was talking to that. Whatever the crank sensor was talking to this. All right, the only wire we're concerned about is this one right here. You can get rid of all the other wires on the screen and put your phone away. And this right here is the only wire we care about, right here. All right, got that? Remember that wire, PIP wire, goes to that pin right there. When performing a load test on a battery, a technician finds the battery voltage drops below specs. Which of the following is the most likely actually perform? Now, below specs means a 15-second load at half the cold cranking amps. It shouldn't go below 9.6. If it goes below 9.6, what's the next thing you ought to do? Before you do anything else, what should you do? Recharge, return it to service, recharge and retest, replace the battery, replace the voltage regulator. That's question 7. All right, this is the only wire we care about, and this is where it was going. You notice that gray-orange wire? Right over here, it went through this thing from the shock tower. And it's basic, you see that right there? That's a shield. All those wires are shielded. They basically don't want any outside electrical interference that are sending screwball stuff through that. You might see when we're using our picoscope, if we drag the leads over close to something else, it's going to pick up screwy stuff. You don't want that, right? This is the only wire we care about. So what I did was I disconnected it from the ICM connector, and I disconnected it from the engine control on the other end, and I took all of this apart, and I unwrapped all of that foil tape. And I got this wire in my hand, and it was only about that long. It had the connector on both ends. The reason I was suspecting that wire is when I hooked my service bay diagnostic system up to do a troubleshooting on the circuit, it was showing me it had an open circuit on that gray wire with the orange stripe. I could manipulate this harness right on top of the shock tower, and it just right there in that one spot, it would change. And I said, something's wrong with that wire, and I don't know how that happened in the harness because the harness isn't externally damaged. When I took that wire out of there, I could not ever get it to act up again in my hands. Put my meter on it, I moved it around. So what did I do? Did you put the same wire back in? Heck no. I got the right connectors, put it on each end, got a new wire. This was my this was my buddy right here. This bad boy was my buddy. I don't know how much it cost. It was somewhere between $50,000 and $76,000 when we bought it in 1991. But I used that thing for about 10 years, and man, I just loved it because it told me all kinds of stuff. And furthermore, let me ask you this: if you get a new piece of equipment and you want the people to listen when you got a legitimate complaint, make sure that most of your input's positive. Because I sent those guys all kinds of letters. I love this machine. It does this well. It does that well. It does the other well. And then one day I had a problem with it, and it lied to me, and I burned most of a day trying to fix the truck. And finally, I disconnected from it and had to find the problem the old-fashioned way. And I sent them a letter telling them everything I did, sent them a log file from the machine. And because all of my input up to that point had been positive input, and I had said good things, all of a sudden I'm complaining about this one truck. I got 6 phone calls and 2 personal visits from Ford service engineers. And that was pretty cool stuff. And they says, what can we do to compensate you for the day you lost? I said, compensate the dealership, because the way they're paying me, I didn't really lose a lot. And they didn't compensate nobody. But I found out later that another guy that they had offered that to got a free pickup to drive for a year or something. All right. So from the ICM to PCM, it's about 5 feet long. So I replaced the whole wire. It drove away, fixed. Cranked up, drove away, guy never had any more trouble with it. I just replaced that one wire. Okay, 2 technicians are discussing an alternator with 0 output. Technician A says the field circuit may have an open circuit. Technician B says the fusible link may be open from the battery to the alternator. Who is right? Which part of the alternator is included in the field circuit? Stator, rotor, rectifier, the housing. A charging system is being checked for non-output. This is the last question and we're almost ready to go lunch. Technician A notices a strong magnetic field at the rear bearing on the alternator and claims the brushes are the problem. Technician B says the field is energized and the problem must be related to a charging system voltage drop. Who's correct about that? See, technician A holds a hacksaw blade or a long screwdriver down at the back of the alternator and it grabs the hole while it's running, it grabs the hold of his screwdriver or his hacksaw blade, pulls it in real tight. Is this a field problem or maybe charging system voltage drop? And that's the end of the session today.